Today, when we talk about Antarctica, we're usually talking about extremes. It's the coldest place on Earth. It's the driest, the windiest, and in some places, the most lifeless. Just about everything down there is white, frozen, and quiet. But that's only the latest chapter. Because hidden under all that ice is the fossil record of an entirely different world, one that, at first glance, doesn't seem like it should have existed at all. Palm trees, beech forests, flowing rivers, a subtropical climate, just a stone's throw from the South Pole. 50 million years ago, that was Antarctica. Now that kind of claim usually raises eyebrows, but this isn't myth or speculation. It's built on decades of hard geological evidence, fossils, sediments, ancient pollen, and rock cores pulled from beneath the seabed, all pointing to the same conclusion. Antarctica wasn't always frozen. In fact, for much of its history, it was warm, green, and absolutely thriving. Back then, the Earth itself looked very different. The continents were still drifting toward their current positions. The planet's climate was in what we call a greenhouse phase, a time when the poles were free of ice, sea levels were high, and temperatures across the globe were elevated. Antarctica, which we now think of as a land of snowstorms and creaking glaciers, was forested. Along the coastlines, palm trees lined the beaches. Farther inland, dense forests of beech, conifers, and ferns covered the hills. It looked more like modern-day New Zealand or southern Chile than anything we'd associate with the bottom of the world. And yet, there it was, a continent bathed in warmth, supporting entire ecosystems. It experienced one of the strangest light cycles imaginable. 6 months of daylight followed by 6 months of darkness, yet the plants adapted. Fossilized leaves show growth rings, patterns of light and dark seasons, and evidence of resilience to the polar extremes. Somehow, in spite of it all, life thrived there for millions of years. That ancient warmth wasn't random. It was driven by high levels of carbon dioxide in the atmosphere. Around 50 million years ago, CO2 concentrations were roughly 2 to 3 times higher than they are today. That extra carbon trapped heat and distributed it more evenly across the planet, preventing cold snaps and keeping even the polar regions comfortably warm. Ocean currents circulated differently, moving heat more directly toward the poles. Without permanent ice to reflect sunlight, the planet absorbed even more warmth. In short, everything worked together to keep Antarctica green. So what changed? Well, a few things. First, carbon dioxide levels started to fall. Volcanic activity slowed down, reducing the natural output of greenhouse gases. Meanwhile, weathering, especially of newly formed mountain ranges, began drawing carbon out of the air. Rivers carried dissolved carbon into the oceans, where tiny marine organisms used it to build their shells. When those creatures died, their remains sank to the seafloor, burying carbon in the sediment and locking it away for millions of years. At the same time, the continents were still on the move. Australia and South America drifted away from Antarctica, cutting it off from direct connections with warmer waters. That opened the door for something entirely new, the Antarctic Circumpolar Current. This powerful ring of cold water began circling the continent and essentially built a wall around it, preventing warm ocean currents from reaching Antarctica's shores. That's when the big freeze began. We see the moment it happened in sediment cores pulled from the seafloor. These long layered cylinders are like natural time machines. They record every shift in environment, every drop of mud, every bit of pollen, every shell fragment and mineral grain. And around 34 million years ago, the story in those layers changes. Warm weather pollen disappears. Tundra species take its place. Dropstones, rocks carried by glaciers and dropped into the ocean, start showing up in the sediment. And then, unmistakably, there's glacial till, coarse, ground-up rock left behind by advancing ice sheets. Antarctica didn't just cool off, it froze, and once the glaciers got going, they didn't stop. That said, the process wasn't smooth. Earth's orbit changes over time, wobbling slightly in regular cycles. These orbital shifts affect how much sunlight reaches the poles and when. As a result, Antarctica went through glacial and interglacial periods, alternating phases of advancing and retreating ice, playing out over tens of thousands of years. The evidence for these shifts lies in alternating sediment layers, thick, heavy debris from glaciers, followed by finer, organic-rich muds from warmer intervals. It's all still there, quietly chronicling Earth's ancient rhythm beneath the waves. But perhaps the most stunning discovery came from a drill core taken from West Antarctica. This core revealed something almost unbelievable, a preserved section of ancient rainforest soil, complete with fossil roots, pollen, and even the microscopic structure of plant cells. It was dated to about 90 million years ago, during the time of the dinosaurs. Temperatures back then averaged around 12 degrees Celsius annually, with summer highs pushing toward 19 degrees Celsius. This wasn't just forest, it was a lush, swampy rainforest, full of life and warmth. That discovery rewrote the book on polar climate history. To sustain a rainforest so close to the South Pole, carbon dioxide levels would have had to be much higher than scientists previously thought for the Cretaceous period. And not just a little higher, dramatically higher. It was, by all accounts, one of the warmest stretches in the last 140 million years. Sea levels were over 170 meters higher than they are now. Dinosaurs were still walking the Earth. In Antarctica, it was green. So what does all this tell us? Well, for one thing, Antarctica has changed. A lot. And not just over tens of millions of years, but in geologically short bursts. The rise and fall of CO2, the shifting of ocean currents, the movement of continents, each one has flipped the climate switch before, and they can do it again. Right now, the levels of CO2 in our atmosphere are climbing rapidly, faster than at almost any point in Earth's history. Ice is already melting at the edges of Antarctica. Glaciers are retreating. Sea levels are beginning to rise. The same forces that transformed the continent once are stirring again. Only this time, it's not volcanoes or drifting land masses. It's us. No, we're not expecting palm trees to spring up on the Ross Ice Shelf anytime soon, but the point is, dramatic change is possible. It's happened before, and under the right conditions, it can happen fast. Buried beneath Antarctica's ice lies a quiet warning. Its fossil forests aren't just echoes of a vanished world. They're reminders that Earth's climate isn't fixed. It's dynamic. It's reactive, and it doesn't wait for permission to shift. If we want to understand where we're going, it helps to start by looking under the ice and remembering what used to grow there.